Can you see the screen now?
Yes, ma'am.
Okay. So today we will do some problems on beta function and gamma function, and hopefully we can complete it today. So the first problem in beta function and gamma function, integration 0 to 1 dx by root over 1 minus x to the power n equal to this. You have to show it. So we start from this integral and we take, here we take x to the power n equal to sine square theta, because without any substitution it is impossible to evaluate this integral. You know, 1 minus sine square theta is cos square theta, and root over 1 minus cos square theta is cos theta. So it will be something easier. So n x to the power n equal to sine square theta. Take the differential, n x to the power n minus 1 dx equal to 2 sine theta cos theta d theta. Now adjust the limits. When x equal to 0, sine theta should be 0, so theta should be 0. When x equal to 1, 1 to the power n is 1, so sine theta 1, that means theta equal to pi by 2. And here from this substitution, x to the power n equal to sine square theta, so x should be equal to sine to the power 2 by n theta. And here you see dx equals to 2 sine theta cos theta d theta divided by n into x to the power n minus 1. So what is the value of x to the power n minus 1? This is the value of x. So x to the power n minus 1 theta should be, take the power n minus 1 of this one from the right side, sine to the power 2 by n theta whole to the power n minus 1. That means ultimately it should be 2, the power will be 2 into n minus 1 divided by n. So let us use it here. You see the limits of the integral is changing from 0, 1 to 0 to pi by 2. Dx means 2 sine theta cos theta d theta divided by n into x to the power n minus 1. This is the value of x to the power n minus 1. So we put it here, and from this factor root over 1 minus x to the power n, we are getting cos theta. So 1 cos theta is cancelling out. We can take this 2 by n outside the integral, and here the power of sine theta is 1. So ultimately it should be, when you take this sine to the upper side, the power of sine will be 1 minus 2 plus 2 by n. 1 minus 1 minus 2 plus 2 by n. So ultimately 1 minus 2 is minus 1 and plus 2 by n. So here the power of sine is 2 by n minus 1 theta. Okay, now here we use this relation. We have got it earlier and already we have used it several times. We know that integration 0 to pi by 2 sine to the power m theta cos to the power n theta d theta equals to gamma m plus 1 by 2 into gamma n plus 1 by 2 divided by 2 into gamma m plus n plus 2 divided by 2. So here the value of m is 2 by n minus 1 and the value of n is 0. So n is 0 and m equals to this. So put it here in this formula and then simplify. And then simplify. In the upper side it becomes gamma 1 over n, and here gamma half equals to root over pi. Here 2 minus 1 is 1. And then you add it, LCM will be n, which comes here. So in the lower part we have 2n and in the upper part 2 plus n. Now here if you separate these two terms, the first term will be 1 over n, the second term should be half. So this is the value of this integral. And in the original integration I equals to, there was a 2 by n outside, so 2 by n into this, I will be equal to, the value of the integral will be 2 by n. These 2 and these 2 will cancel out, so there is another 2 by n. Actually it was 2 by n, so that 2 and these 2 will cancel out, so you will have root over pi by n into this, gamma 1 over n divided by gamma 1 by n plus half. So we have proved it. Now look into this. It was coming in our properties. It comes in our properties, but we didn't actually prove it. So now let us see how can it be proved. Beta mn equals to 0 to integral 0 to infinity x to the power n minus 1 divided by 1 plus x whole to the power m plus n. We start from the definition of beta function. Beta mn equals to this 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1 dx. Let us have a substitution. Suppose x equal to 1 over 1 plus y. So dx will be minus 1 by 1 plus y whole square into dy. Now we go back to the definition and adjust the limits. When x equal to 0, y must be infinity because 1 over infinity is 0. And when x equal to 1, y should be 0. So the lower limit is infinity and the upper limit is 0. Okay. Now what is the value of x? X is 1 by 1 plus y. So for this power m minus 1, it should be 1 by 1 plus y whole to the power m minus 1. And here then within the bracket, let us use a third bracket here, 1 minus x. X means this 1 by 1 plus y, and the power here is n minus 1. Okay. And what is the value of dx? Dx equals to minus dy by 1 plus y whole square. We put this minus sign here. Now we adjust this minus sign with the limits. So it becomes 0 to infinity. Now you just do this algebra. Here you do this subtraction. In the upper part it will be 1 plus y minus 1. So 1 minus 1 will cancel out. In the upper part we will have simply y. So y to the power n minus 1. In the lower part, how many 1 plus y are there? 1 plus y, this is also 1 plus y, this is also 1 plus y. So 1 plus y whole to the power m minus 1 plus 1 plus 2. So minus 1 plus, oh sorry, this is n minus 1, I'm sorry. M minus 1 plus n minus 1 plus 2. So minus 1 and minus 1 plus 2, they cancel, there remains m plus n. Yes. Now you just change the variables. In place of y, let us write x. So it will be beta mn equals to 0 to infinity x to the power n minus 1 divided by 1 plus x whole to the power m plus n dx. This was the thing to be proved. So it has been proved here. Now next integral 0 to 1 x to the power m into 1 minus x to the power n whole to the power p dx. So here it is of the form something like beta function. So let us take x to the power n equals to z. Suppose x to the power n equals to z. So x will be z to the power 1 by n. Now take the differential n into x to the power n minus 1 dx. It should be dz. So what is the value of dx? Dx will be dz divided by n x to the power n minus 1. Okay, and adjust the limits. When x equal to 0, z is 0. When x equal to 1, z is 1. So there is no change in the limit. And what is the power of x? Here it was m, and here from the value of dx you have got dz by n into x to the power n minus 1. So if you take it to the upper side, it should be minus n plus 1. So this is the power of x, and here 1 minus z whole to the power p dz divided by n, and this part x to the power n minus 1 is adjusted here. Okay, now what is the value of x? X is z to the power 1 by n. So this x to the power m minus n plus 1 should be equal to z to the power 1 by n whole to the power m minus n plus 1. That means ultimately the power of z should be this, m minus n plus 1 divided by n, and here 1 minus z whole to the power p. Now you adjust these factors, the powers of these factors to get beta function. The definition of beta function was it was x to the power n minus 1 into 1 minus x whole to the power n minus 1. So here we try to get something like n minus 1. So 1 plus z whole to the power, let us write it p plus 1, so minus 1. So here n is p plus 1. And what should be your n? Okay, you separate the terms like this, m plus 1 divided by n, then minus n by n, which is 1. So here in place of m, you have m plus 1 by n. So, and the limits are 0 to 1. So this is nothing but, we can use here beta function, definition of beta function. Your m is this. M plus 1 by n is your m, and p plus 1 is your n. So beta mn. Now you can use the relation between beta function and gamma function. Beta mn equals to gamma m into gamma n divided by gamma m plus n. You just use it here. Also no problem if you give your answer in this way in terms of beta function. Now next question. Here you see the limit is 0 to 1, x to the power m minus 1 plus x to the power n minus 1 divided by 1 plus x whole to the power m plus n. We have to show that this is nothing but beta function, beta of mn. So at first we separate these two integrals, 0 to 1, x to the power m minus 1 by 1 plus x whole to the power m plus n dx, and then plus integral 0 to 1, x to the power n minus 1 by 1 plus x whole to the power m plus 1 m plus n dx. Now we have shown that this is beta mn if the limit is 0 to infinity. We have done it here. Please don't confuse. You see here beta mn equals to 0 to infinity. Integral 0 to infinity function is same. X to the power n minus 1 divided by 1 plus x whole to the power n plus n. But the limits are different. If the limit here is 0 to infinity, the value of this should be beta mn. Here also the value should be beta mn, but here the limits are not 0 to infinity 1. 0 to infinity, it is 0 to 1. Okay, so let us give a name here. Suppose it is I1 and suppose it is I2. So we start from I2, 0 to 1, x to the power n minus 1 by this. Let us take the substitution x equal to 1 over y, because we need the limits 0 to infinity. So here dx equal to minus 1 over y square dy. Adjust the limits. When x equal to 0, y must be infinity. When x equal to 1, y should be 1. So your limit will be now infinity up to 1. Yes. And here x means 1 over y. So 1 over y whole to the power n minus 1 divided by 1 plus in place of x 1 by y whole to the power n plus n. Now dx value is minus 1 over y square dy. We put this minus sign outside and here dy by y square. Now you do this algebra. Here at first we adjust the limits with this minus sign. Remove the minus sign and the limits will be 1 up to infinity. And this factor will be 1 by y to the power n minus 1, and do this addition. LCM is y, and in the upper side y plus 1. So this y can be taken to the upper side. It should be y to the power n plus n divided by 1 plus y whole to the power n plus n, and then dy by y square. Now what comes for the power of y in the upper side? It will be n plus n minus n plus 1 plus 2. So minus 2, sorry. M plus n minus n plus 1 minus 2. And ultimately it will be m minus 1. N and minus n will be cancelled out. And in the lower side, 1 plus y whole to the power m plus n. You just change the variables. It can be written as integration 1 to infinity x to the power m minus 1 divided by 1 plus x whole to the power m plus n dx. Now you put the value of I2 in equation number 1 here. So this was the integral given to us, and now you are getting this 0 to 1, this integral, plus in place of this I2 we have got 1 up to infinity, the same thing, same function. 0 to 1 x to the power m minus 1 divided by 1 plus x whole to the power m plus n, and here x to the power m minus 1 divided by 1 plus x whole to the power m plus n. Now remember here, okay, no problem, here we are getting power, okay. So this is also true if in place of m we have n, no doubt in it. So now the function is exactly same, but the limits are 0 to 1 and here 1 up to infinity. So you can combine these two with the limits of the integral 0 up to infinity. And this was the thing to be proved, which is nothing but beta mn. So one thing to show that this is equal to beta mn, you have to do the parts that is done here. You must include this part, that this integral equals to beta mn, okay? You have to show this proof that beta mn equals to this. Must include it here. We have to show this proof. Yes, this proof. Okay, next. Integral 0 to 1 x square dx by root over 1 minus x to the power 4 into 0 to 1 x, dx by root over 1 plus x to the power 4. What is the difference between the functions? Here there is x square, there is no x square, and here in place of minus sign you have plus sign. Okay, we named this integral as I1 and this one as I2. We start from I1. So here we take x square equal to sine theta. So 2x dx will be cos theta d theta. Now adjust the limits. So when x equal to 0, theta should be 0. When x equal to 1, theta should be pi by 2. So 0 to pi by 2. And here x square means sine theta. And dx means, x square means sine theta and dx means cos theta d theta divided by 2x, means divided by 2 sine theta. What is the problem here? Oh, yes. It should be x square. X square equals to sine theta. So x should be root over sine theta. It is written here. So dx equal to cos theta d theta divided by 2x. That means dx equal to cos theta d theta divided by root over 2 into root over sine theta, right? And from this factor root over 1 minus x to the power 4, you are getting cos theta. So 1 cos theta cancel out, and here the power of sine should be 1 minus half. That means just half. So you can apply here the gamma formula involving gamma function. Here m is half and n is 0 because there is no cos theta here. So the value is integral is 0 to pi by 2, half should be there, and your m is half and n is 0. So gamma half plus 1 by 2 into gamma 0 plus 1 by 2 divided by 2 into gamma half plus 0 plus 2 divided by 2. Now you simplify this and get the, okay, it is not the final result, actually it is the value of the first integral. Now we go to the second integral. Here the substitution must be different because the sign is not minus, it is plus. So let us take x square equal to tan theta. So 2x dx should be sec square theta d theta. And what are the limits? When x equal to 0, theta should be 0. When x equal to 1, theta should be pi by 4 because tan pi by 4 is 1. Okay, now dx equals to sec square theta d theta divided by 2x. That means sec square theta d theta divided by 2 into root over tan theta. Yes. And here root over 1 plus tan square theta means sec square theta. For this root over you will get sec theta. So 1 sec theta will be cancelled out. In the upper side only sec theta, in the lower side root over tan theta, this half is taken outside. Now, now you see, let us write this sec theta as 1 over cos theta and in the lower part it is root over sine theta by cos theta. So if you take root over cos theta to the, oh no, it is not taken to the outside, out to the upper side, 1 by cos theta, 1 by cos theta here into here sine theta by cos theta. So that means cos theta is multiplied here. Yes, cos theta is multiplied here. This cos theta, when taken under the square root, it should be cos square theta, and 1 cos theta from this 10, 1 cos theta will be cancelled. So ultimately it should be root over sine theta cos theta, which is nothing but half sine 2 theta. Half sine theta, when this half means 1 by root 2, when it is taken to the upper side, it will be just root 2. So half, there was already a half here, root 2 by 2 into integration 0 to pi by 4 d theta divided by root over sine 2 theta. Now let us take a substitution, say 2 theta equal to u, so 2 d theta should be du, so d theta should be du by 2. Now adjust the limits. When theta equals to 0, u should be equal to 0. When theta equals to pi by 4, theta should be pi by 2. So here for I2 you are getting this, and this 1 by root over sine u means sine to the power minus half u, and the power of cos is 0. You just use the formula for this integral and then simplify, put down the value here, which is I1 into I2, and then do the simplification, you are getting this result. Next, I think this one is easy. You just take y equal to a sine theta. Yes, y equal to a sine theta. So dy will be a cos theta d theta. When y equal to 0, theta should be 0. When y equal to a, sine theta should be 1. So theta should be pi by 2. So 0 to pi by 2, y to the power 4 means a to the power 4 sine to the power 4 theta. And here root over a square minus a square sine square theta, that means a cos theta, right? And for dy, you are getting another a cos theta d theta. So ultimately, you are getting a to the power 6, which is kept outside, 0 to pi by 2 sine to the power 4 theta, and here cos square theta. So you know integral 0 to pi by 2 sine to the power m theta into cos to the power n theta d theta equals to root over m plus 1 by 2, sorry, gamma, I'm sorry, very sorry, gamma m plus 1 by 2 into gamma n plus 1 by 2 divided by 2 into gamma m plus n plus 2 divided by 2. And gamma, remember, gamma half is root over pi, so you can do it. I think this math is not necessary. It is very easy. Now you go to this one. Okay, here one thing, here I have done this integral using substitution twice, but actually we don't need 2 times substitution. From the very beginning you can write 2y square equal to x. So finally the second substitution will not be necessary. So anyway, let us try to understand this one. Suppose 2y square equal, sorry, just y square equal to x. So 2y dy equal to dx. When x is 0, y is 0. When x is infinity, y is infinity. So no change in the limits. And y square means x. And here y square means x. So e to the power minus 2x dx by dy. Why? Because dy equals to dx by 2y. Now you put down the value of y. Y means root over x. So it should be 2 into root over x. This 2 is taken outside as half. And here, what is the power of x? X by root over x. That means root over x. That means x to the power half. And here e to the power minus 2x. So here we need another substitution. Suppose 2x equal to t. So dx, 2 dx should be dt. That means dx equal to dt by 2. And the limit are not changing, so here you are getting 1 by 4 into root 2 integral 0 to infinity t to the power half e to the power minus t. So let us write it in this way, 3 by 2, the power half can be written as 3 by 2 minus 1. So in place of n you have 3 by 2, and it is here we can easily use the definition of gamma function, which is 0 to infinity t to the power n minus 1 into e to the power dt, which is nothing but gamma n. In place of n you have 3 by 2, so this 1 by root 4 into root 2 into gamma 3 by 2. And gamma 3 by 2 can be written as half into gamma half. So gamma half is root over pi. This is the answer. Now this one, here also you need a substitution. Suppose x square equal to 16t, because there is a 16 here. We want to take 16 common so that you can get 1 minus sine square theta. Okay, no, sine theta is not included here, just x square equal to 16t. Actually, from the very beginning, you can write 16 sine square theta. Definitely, didn't we use it? Oh no, we didn't use it here. Okay, there are several ways to perform an integration, no problem. So here at first we are taking x square equal to 16t. So x should be equal to 16t whole to the power half. That means 4t to the power half. And dx, 2x dx equal to 16 into dt. So dx should be equal to 16 by 2x into dt. And the limits are changing in this way. See, when x equal to 0, t equal to 0, when x equal to 4, it will be 16, so t should be 1. Yes. Now the limit becomes 0 to, this integral will be equal to 0 to 1. For x, it is 4t to the power half, so 4t to the power half whole to the power 3 by 2. And here 16 minus 16t whole to the power half. And what is the value of dx? Dx is 16t, that means 8t divided by x. Okay, and now here put down the value of x. X is 4 into t to the power half. Okay, now you do the algebra. Here for another 4 comes out, so 4 to the power 3 by 2 into 4 to the power 3, it is coming here, and 16 to the power half, that means 4, and this 8. Okay, now t to the power 3 by 4 divided by the value of x is 4t to the power half, and here 1 minus t whole to the power half. Very easy. So 3 by 4 minus half, it gives you 1 by 4. Now it goes to the formula for beta function. Let us write this 1 by 4 as 5 by 4 minus 1, and this half as 3 by 2 minus 1. So your m is 5 pi by 4 and n is 3 by 2. So this is nothing but beta 5 by 4 comma 3 by 2. Now write down the relation in between, use the relation in between beta function and gamma function. So this beta mn equals to gamma m into gamma n divided by gamma m plus n. Okay, now you simplify, you are getting this result. The answer for you. Okay, not, it can be simplified. Okay, no problem. No, it is not possible, because it is 21 and it is 8 into 16. 8 into 16 means 128. Yes, and here gamma 1 by 4 is there, and here it was 5 by 4 plus 3 by 2, which was 11 by 4, and use the property of gamma function, it will be 7 by 4 into 3 by 4 into gamma 3 by 4. So this 3 into 7 gives you 21, 4 into 4, 16 also. Okay. Now this one, so that gamma 2n plus 1 divided by 2 equals to this. Okay, we start with this property, that integration 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2n minus theta d theta. It is nothing but gamma m into gamma n divided by 2 into gamma m plus 1. We have seen it earlier. We have got this relation earlier. So here, let us put 2m minus 1 equals to 0, and which gives you m equal to half. So this integral now becomes, we are putting here 2m minus 1 equals to 0. So there remains only cos to the power 2n minus 1 theta. So here you can use this formula in which m equals to half. We can use this formula where m equals to half, and It was gamma m into gamma n. Yes, it is cos to the power 2n minus 1. So it should be gamma half into gamma n divided by 2 into gamma half plus n. Yes, half plus n. So now let us use Wallis formula for the left side integral. What was Wallis formula? Do you remember? Integration 0 to pi by 2 cos to the power n theta d theta. It will be n minus 1 by n into n minus, it should be what? N minus 1 by n. Then here comes n minus 2 in the upper side, it should be n minus 3 and so on. So here using Wallis formula, it will be 2n minus 2 divided by 2n minus 1 into, here it should be 2n minus 3 in the upper side, 2n minus 4. In the next factor, it should be, in the lower side, it should be 2n minus 6 in the upper part, 2n minus 8. I'm sorry. In the lower part, it should be 2n minus 5. In the upper part, it should be 2n minus 6. So you see, in the upper part, all the numbers are even. 2n minus 2, 2n minus 4, next 2n minus 6, etc. All the numbers are even. So here, ultimately, you will get this for this integral 4 to, and when it is 4 under it, it will be 5. When it is 2 under it, it will be 3. So according to Wallis formula, the last factor should be 1. And in the right side, you are getting gamma half means root over pi, gamma n, and here it should be 2 into gamma 2n plus 1 divided by 2. And from the left side, now we do apply some technique. You take 2 common from each factor in the upper side. So here 2, another 2 here. Ultimately, there will be n, 2 will be n minus 1 times in the upper part. So it should be 2 to the power n minus 1. So here remains n minus 1, n minus 2, n minus 3, and here 2 into 1, okay, 3 into 2 into 1. In the lower side, 2n minus 1, 2n minus 3, etc. 5, 3, 1. Okay. Now, in the upper part, it is nothing but factorial n minus 1. It is nothing but factorial n minus 1. And in the lower side, we just write the factors from the right side. 1, 3, 5, 7 up to 2n minus 1. At the right side, this is the result. Gamma n, you know, gamma n plus 1 is factorial n. So gamma n should be equal to factorial n minus 1. So this factorial n minus 1 and this factorial n minus 1, they cancel out. So what should be the value of this? Gamma 2n plus 1 divided by 2. It should be equal to this part, these factors goes up. 1 into 3 into 5 into up to 2n minus 1, and then root over pi divided by 2, and here another 2 to the power n minus 1, so ultimately 2 to the power n. So this is proved here. Now we will find here some values of gamma function when n is 0, when n is minus 1, when n is minus 2, etc. We will use this relation gamma n plus 1 equal to n into gamma n. So gamma n equals to gamma n plus 1 divided by n. So if you put n equal to 0, it should be gamma 1 by 0. Gamma 1 is 1. So 1 by 0, it is infinity. And now gamma minus 1, you just put here n equal to minus 1. So in the upper part, you are getting gamma 0, minus 1 plus 1, it is 0, divided by n is minus 1. Gamma 0 is infinity, but because of this minus sign, it should be minus infinity. Now here you put n equal to minus 2. So gamma of minus 2 will be equal to minus 2 plus 1, that means minus 1. So gamma minus 1 divided by minus 2. Gamma minus 1 is minus infinity, and there is minus 2. Minus minus cancel out, so you are getting infinity. So in this way, you can show that gamma minus 3 should be minus infinity, gamma minus 4 should be plus infinity, and so on. So you see, for gamma, for negative integer, gamma n is either infinity or minus infinity. If n is negative and not an integer, for example, n equals to minus half. You see, these are different. When n equal to minus half, what comes? Gamma, according to this relation, gamma n equals to gamma n plus 1 by n. So gamma minus half. Just put n equal to minus half. Gamma minus half should be equal to gamma minus half plus 1, which is gamma half. And gamma half is root over pi. And in the lower side, it is minus half. That means minus 2. So you see, you are not getting any infinity here. When the numbers are negative fractions, minus half. Minus 2 into root over pi. So similarly, if you put n equal to minus 3 by 2, it will be gamma minus 3 by 2 will be equal to gamma minus 3 by 2 plus 1 divided by minus 3 by 2. And gamma minus 3 by 2 plus 1, it means gamma minus half. And the value of gamma minus half is minus 2 into root over pi. And this becomes minus 2 by 3. So ultimately it is plus 4 by 3 root over pi and so on. So gamma n has infinite values when n is negative, but yes, gamma n has finite values, not infinity. Gamma n has finite values when n is negative, but it is not an integer. It is a very important result. Now there is another proof here, which is also very important. Show that integration 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1 divided by a plus x whole to the power m plus 1. The value should be shown as beta mn divided by a to the power n into 1 plus a whole to the power m. We start with the definition of beta function. We start with the definition of beta function. Integration 0 to 1. This here, let us use this substitution. Actually, if you do not know the type of substitution, it is not possible. If you do not have any practice, it is not possible to solve this math in your exam. So you need to do practice. X equal to 1 plus a into z divided by a plus z. This is our substitution. So we can write this in this way also. Put 1 plus a outside and z by a plus z can be written as 1 minus a by a plus z. So when you take the differential, dx will be equal to 1 plus a, then what? Minus a into minus 1, so it becomes plus a into 1 over a plus z whole square dz, right? Again, from this relation, ax multiply crosswise, ax plus xz equals to 1 plus a into z. So here you take z common in the left side, so it should be 1 plus a, yes. Okay, no, actually I'm taking this xz to the right side and then take z common. So it should be z into 1 plus a minus x. And in the other side, it should be ax. So what is the value of z? Z equals to ax divided by 1 plus a minus x. This is the value of z. So now you adjust the limits. What the limits were a 0 to 1 for x. So let us put it here. When x is 0, definitely z will be 0. When x is 1, when x is 1, 1 and minus 1 cancel out, a cancel out, so z should be 1, yes. So you see the limits are not changing. When x equal to 0, z equals to 0. When x equal to 1, z equal to 1, okay. So we go back to the integral of in the definition of beta function 0 to 1, and the value of x is this 1 plus a into z by a plus z, and here the power is m minus 1, so all the powers should be m minus 1. 1 plus a whole to the power m minus 1, z to the power m minus 1 divided by a plus z whole to the power m minus 1, and then within bracket let us use a third bracket here, 1 minus, what is the value of x? This 1 plus a into z by a plus z, and the power is n minus 1. And what is the value of dx? Dx is this 1 plus a into dz divided by a plus z whole square. Okay. Now you do the algebra. 1 plus a whole to the power, yes, there is another 1 plus a, so the power should be just m. Okay, and here z to the power m minus 1, and what is coming here? A plus z, LCM is a plus z, and here a plus z minus z minus az. So z will cancel out. Yes, a minus az whole to the power n minus 1, and there is a here. And in the lower side, all the factors are a plus z. So the power should be m minus 1 plus n minus 1 plus 2. Yes, ultimately minus 1 plus 2 will cancel out. It will be m plus n. Okay. Here you take a common, so a to the power n minus 1 into 1 minus z whole to the power n minus 1. This a and a to the power n minus 1 will give you just a to the power n. Okay, so 1 plus a whole to the power m, a to the power n, z to the power m minus 1, 1 minus z whole to the power n minus 1 divided by this. So here you just take these parts common. In the left side it was beta mn. So to get the value of this integral, you have to take these factors 1 plus a whole to the power m, a to the power n to the left side. So it should be beta mn divided by 1 plus a whole to the power m into a to the power m. And there remains under the integral z to the power m minus 1, 1 minus z whole to the power n minus 1 divided by a plus z whole to the power m plus n dz. You just write the variable x in place of z. So you are getting the value of this integral, which is beta mn divided by this. So this file is complete. I am now taking another one. Okay, let us see up to what we can go. Okay, so there are some maths here. So this is integration 0 to 2x into cube root of this. So here let us take x cube equal to 8y, so that you can get the expression for beta function. Yes. So let us take x cube equal to 8y, so 3x squared dx equal to 8dy. And just the limits, when x equal to 0, y should be 0. When x equal to 2, it should be 8, so y should be 1. So the limit now becomes 0 to 1. Here the value of x should be 8y whole to the power 1/3. That means 2 into y to the power 1/3. Okay, now here we take 8 common. And for this dx, it would be 8 into dy divided by 3x square. Now you put down the value of x is 2, y to the power 1/3. So for x square, it should be 2y, 2 into y to the power 1/3 whole square. Okay, do the algebra. And ultimately you are getting this, y to the power 1/3 minus 2 by 3, yes. And here 1 minus y whole to the power 1/3. Take the constant factors outside the integral. So now you just try to get the expression for beta function. This minus 1 over 3 can be written as 2 by 3 minus 1, and this 1 over 3 can be written as 4 by 3 minus 1. So m is 2 by 3 and n is 4 by 3. So this is nothing but beta of 2 by 3, 4 by 3. And then you use the relation between beta function and gamma function. So gamma 2 by 3, gamma 4 by 3 divided by gamma 2 by 3 plus 4 by 3. Okay, so in the upper side, gamma 2 by 3 and this gamma 4 by 3 can be written as 1 over 3 into gamma 1 by 3. And here 4 plus 2 is 6, so gamma 2, yes. And here the constant factor is 8 by 9. Gamma 2 means 1 into gamma 1, which is just 1. And here this gamma 2 by 3 into gamma 1 by 3. Let us write this gamma 1 by 3 in the left side, and this 2 by 3 can be written as 1 minus 1 over 3. So it goes like this: gamma p into gamma 1 minus p. Gamma p into gamma 1 minus p. We have seen that there is a very important result for this, which is pi by sine p pi. Here p is 1 over 3. So ultimately it should be pi divided by sine pi by 3, and sine pi by 3 is 60 degrees, so root 3 by 2. So this is the result. Next, integration 0 to infinity e to the power minus x to the power 4 x squared dx, and here 0 to infinity e to the power minus x to the power 4 dx. The difference is here there is an x squared, there is no x squared. So let us suppose that x to the power 4 equal to t. So 4x cubed dx equal to dt. So x cubed dx will be equal to dt divided by 4. Okay, so here you write this x square as x cubed by x. Yes, x cubed by x, and here x cubed by x cubed, right? So because you know the value of x cubed dx is dt by 4. So here comes e to the power minus t, because x to the power 4 is t, e to the power minus t, and x cubed dx is dt by 4. So dt by 4, and the value of x is t to the power 1 by 4, right? And here integration 0 to infinity e to the power minus t x cube dx means d by 4, and for this x cube, x is t to the power 1 by 4, so x cube should be t to the power 3 by 4, right? So here in the first integral, this 1 over 4 and 1 over 4 can be taken outside. T to the power minus 1 by 4 e to the power minus t dt. And here t to the power minus 3 by 4 into e to the power minus t dt. So let us try to get the expression for gamma function. This minus 1 over 4 can be written as 3 by 4 minus 1. And this minus 3 by 4 can be written as 1 by 4 minus 1. So for the first integral, your n is 3 by 4, and for the second integral, n is 1 by 4. So it is gamma 3 by 4 into gamma 1 by 4. And you see, this 3 by 4 can be written as 1 minus 1 by 4. So it goes into the formula gamma p into gamma 1 minus p, which is nothing but pi divided by gamma p pi. Your p is 1 over 4, and sine pi by 4 is 1 by root 2. So this is your result. Very important math. Evaluate integration 0 to infinity e to the power minus x to the power n dx, and hence find the value of this. Okay, so here our substitution should be this: x to the power n equal to y, which gives x equal to y to the power 1 over n. Take the differential n into x to the power n minus 1 dx equal to dy. When x is 0, y is 0. When x is infinity, y is infinity. So 0 to infinity e to the power minus y into 1 over dx. Dx is dy divided by n x to the power n minus 1. So what is the value of x? X is y to the power 1 by n. So the power of this y for this power n minus 1, it should be n minus 1 by n. So we take it to the upper side. Actually in the lower side it was 1 minus 1 by n. When you take it upper side, it should be 1 by n minus 1. So it goes directly to the formula for gamma function, where n is 1 over n. And there was 1 by n outside. So 1 over n into gamma 1 by n. So this is the value of this integral. Integration 0 to infinity e to the power minus x to the power n is 1 over n into gamma 1 by n. Okay, this is the result for this integral, and here you just put n equal to 2 for this integral. So it should be half into gamma half, that gamma half is pi. So root over pi by 2. Very, very important result. In some higher math, you can use this result directly. This is known as error integral. It has a name. It is known as error integral. Now the next math. Okay, we do not have time. I am taking just 2 or 3 minutes more. 0 to 1 root over ln of 1 by x dx. So let us take this substitution. Ln of 1 by x equal to z square. So 1 over x should be e to the power z square. So x should be e to the power minus z square. Okay, now dz should be minus 2z e to the power minus z square dz. Adjust the limit when x equal to 0, ln infinity, z square should be ln infinity, e to the power z square should be infinity, and z square should be infinity. Yes, ln infinity is z square, so infinity should be e to the power z square, and that means if some e to the power something is infinity, then the power should be infinity. Okay, so the upper limit is infinity, 0 to infinity. And here dx equal to 2z minus 2z e to the power minus z square dz, and this is nothing but root over z square, that means z. Okay, so z square e to the power minus z square. Let us write it in this way, z e to the power minus z square into z dz, into z dz. So let us here use another substitution. Suppose z square equal to y. So 2z dz equal to dy. When z equal to 0, y is 0. When z is infinity, y is infinity. So here comes z square equal to y. So z should be y to the power half. And e to the power minus y. And z dz is dy by 2. Again, you see, you are applying the formula for gamma function. Here n is 3 by 2. So gamma 3 by 2, which means half into gamma half is pi. So the result here is also root over pi. I think you can do the rest of this math by yourself. Please go through it. I'm not taking this file again in our next class. These problems are not so hard. You can do it by yourself, okay? In the next class, we will start from tangents and normals. But if you need, we can do something from this file also in our next class. Okay, our time is over. Here we have done up to which page? We have done up to page number 3. So if you want, we can start from page number 4. From page 4. Okay. So I am ending our class here. I can't hear you.
আগের ক্লাসের পিডিএফটা আপলোড করা হয়নি।
Oh, I'm sorry. Yes. It was not uploaded. I'm sorry. It will be uploaded today.
মিস আরেকটাও আপলোড করা হয়নি, ওই যে ইন্টিগ্রেশন অ্যাজ দ্য লিমিট অফ সাম, এটা।
That means the last 2 classes.
Yes, miss.
Last 2 classes, okay. Last 2 classes.
And মিস আরেকটা কথা ছিল, আপনি কি সেকেন্ড সিটিটা নেবেন, মানে দুইটা সিটি, ওইটা কি আপনি?
হ্যাঁ, এখন না, সেকেন্ড সিটিটা আমি আরো পরে নিচ্ছি, কেমন? এখন না, আমি তোমাদেরকে ডেট দিয়ে দিব, বাট নট নাও।
ওকে মিস।